Welcome students. uh, Today we are going to discuss about some of the problems which are coming under the three element rectangular rosette. Since theoretical part we have covered in the last couple of videos, today we are going to have the problems because it's the very important part of this syllabus, since you are going to get whatever the questions, the maximum marks will be for the problems only. So this is the first problem. It's very simple. Just see here. If you for the problems you require the basic equations. Okay, so for the basic equations are available in last videos, so you can, if you are not seeing those videos, it's difficult to understand this, but I will try to make some capable understanding for that. Okay, so see here the first problem. The following readings of strain were obtained. This is the problems on three element rectangular rosette. Okay, so the following readings of strain were obtained on a rectangular strain rosette mounted on aluminium for which capital E, that is the Young's modulus, which is equal to 70 GPa, and mu, it is nothing but the Poisson's ratio, that is 0.32, and epsilon A, that is the strain in the A strain gauge, that is 285 into 10 raised to minus 6, epsilon B, which is equal to 65 into 10 raised to minus 6, and epsilon C, which is equal to 102 into 10 raised to minus 6. Determine the principal strains, principal strain directions, principal stresses, and maximum shear stress. So these are the things which you have to determine in here. So these are the given data. So as I said, the Young's modulus, that is 70 GPa, and the nu, it is the Poisson's ratio 0.32. Epsilon is the strain, which is a measured strain. Means if you are conducting a three element rectangular rosette measurements, what you have to do, you are having on measuring meter. Okay, whatever the strain which is available, which is obtained from the strain gauges, it will shows the value. Okay, so that values they are given, that is epsilon A, epsilon B, and epsilon C. These are the values. What are the things you have to find? The principal strains, epsilon 1 and epsilon 2, and the gamma max. Then principal directions, that is phi 1 and phi 2, and the principal stresses, that is sigma 1, sigma 2, and tau max. These are the things you have to determine. Okay, so next, just go to the solution. In here you have to remember this equation. So for the principal strain determination, you have to remember this equation. This is the epsilon 1 comma 2, that is epsilon 1 and epsilon 2, which is equal to epsilon A plus epsilon C by 2 plus or minus half of root of epsilon A minus epsilon C whole square plus 2 epsilon B minus epsilon A minus epsilon C whole square. So this is the equation which is obtained in the whatever the three element rectangular rosette. So the whatever the derivation, where you have derived the equations in the three element rectangular rosette, where you get this principal strain equation, that is epsilon 1 and epsilon 2. So this equation you have to remember. So in here you have to just substitute the values. Epsilon A, that is 285, you have to substitute 285. 10 raised to minus 6 they have taken outside, so you can put it outside. You can directly write the terms. So epsilon C is 102, and similarly epsilon A minus epsilon C are 285 minus 102. 2 epsilon B, it is nothing but 65 they have given epsilon B. If you multiply with the 2, you will get a 130. Okay, similarly minus of epsilon A, that is 285, epsilon C, that is 102, okay, into 10 raised to minus 6. So what you have to do, you have to simplify this term. First, if you want epsilon 1, you have to add those two terms. If you want epsilon 2, you have to minus these two terms. Okay, for the epsilon 1 you will get this much of value, for epsilon 2 it is this much value. So you got the principal strains. Next, so gamma max, just you can easily remember this gamma max by just you can take this half part, this second part. If you take the second part, this will be a gamma max for this. So same equation will be there. So gamma max is equal to root of epsilon A minus epsilon C whole square plus 2 epsilon B minus epsilon A minus epsilon C whole square. So you have to substitute in here also, and you are going to get the values. Okay, the similar type you have to explain, substitute, and you are going to get a gamma max. So next what you have to do, you have to determine the principal directions. Okay, principal directions, you have the equation, that is 2 tan phi. In the earlier derivation we have done 2 tan phi is equal to gamma, this is 2 epsilon b minus epsilon a minus epsilon c by epsilon a minus epsilon c. That is the equations you are going to get in here. Okay, so you have to remember this equations and this equation also. So you have to substitute the values in here, and you can see 10 raised to minus 6 and 10 raised to minus 6 get cancelled out in here. So you are going to get the term that is half of tan inverse of, in the bracket, minus 1.4037. Okay, so just calculating that, you are going to get the phi 1 value, that is minus of 27 degree 16 inches, that you are going to get. And phi 2 can be determined by just adding the 90. Okay, you are going to get minus of 117 degree 16 inches. So it indicates that it is in third quadrant, okay, where the both values are negative. Okay, you are going to get the phi 1 and phi 2. So principal stresses. Okay, as you have determined the principal strains, you have to determine the principal stresses, sigma 1 and sigma 2. This is the basic equations. You have to remember these things. E by 1 minus nu square into epsilon 1 plus nu into epsilon 2. Sorry, this is a new value. Similarly, sigma 2 is equal to E by 1 minus nu square epsilon 2 plus nu into epsilon 1. So you have to substitute the values and you have to find the sigma 1 and sigma 2. Okay, so you have substituted the Young's modulus, that is 17 to 10 raised to 3, and you have substituted the new value, that is 1 minus 0.3 square, and epsilon 1, that is the value which you have got by calculating in here, that is epsilon 1 and epsilon 2 values. So you have to substitute the similar values in here. You are going to get 0.3 is the new value and 35.75 into 10 raised to minus 6. So you will get the values in megapascals, that is 28.285 megapascal. Similarly, in here, according to the equation, you have to substitute in here also, and you are going to get a sigma 2 value. Okay, so like that. And tau max, as you know, so the tau max general equation, that is sigma 1 minus sigma 2 by 2. So if you substitute the values, you know both sigma 1 and sigma 2 values. So if you just substitute, and you are going to get the tau max. So this is the problem. So it is very simple. This problem, just they have asked to determine principal strains and principal directions and principal stresses. So you have determined by using these things. So this is the way of calculating the first thing. The second problem, before going to the second problem, since you require some basics for this second problem. So what is the basic? You can see here. So the second problem is mainly depending upon the transfer correction factor. Okay, transfer sensitivity correction factor. So before going to that, we have to see what is this transfer sensitivity. So transfer sensitivity, so here I am drawn one strain gauge. This is the loading. A load is applied in this direction along the axis of the strain gauge. In this direction the load is applied, so the strain develops in this direction. So this is the linear strain. So the whatever the strain which develops in this direction, it will be a linear strain. Okay, so but whatever the elements you are going to take, you are going to experience some amount of lateral strain. Okay, not always you are going to get the linear strain. You have to see there is a lateral strain. Okay, so you have to require one correction factor. Okay, so in practical way you have to see that correction factor. So that correction factor is required to get the proper result of transfer strains. Okay, so that's why the whatever the strain which develops in this direction, it is called as transverse strain. So you have to correct this transverse strains to properly get this axial strain. So for that we have some equations. Okay, you can see here the equations are available in here. Okay, as we learned about the transverse strains, two element rectangular rosette, this is transverse strain. Okay, you can see the transverse strain. I have sent this material, so you can read here. In any analysis presented above, the strain gauge readings were assumed to be free from errors due to transverse sensitive effect. However, in actual practice, the effect of transverse sensitivity should be studied while measuring the stresses in biaxial stress field with the strain gauges. If it is found that the error due to the transverse sensitivity effect is significant, the strain gauge reading should be corrected for it. Okay, they are saying there is some transverse sensitivity. If it is there, you have to correct the strain gauges. Okay, for the 2-element rectangular rosette, similar way, just you have to remember these equations. You can see epsilon xx cap and epsilon yy cap. These two values which you are going to get, it is the strain indicated by the gauges. Means you have mounted the strain gauge, they are indicating some value. Those strain values are called as epsilon xx cap and epsilon yy cap in x and y directions. Epsilon xx and epsilon yy are the corresponding corrected strains. Means since there is a transverse sensitivity in these two strains, so it can be corrected by, and that value is called as epsilon xx and epsilon y. Okay, so like that you are going to measure in. So this is the equation you are going to remember for the 2-element rectangular rosette, and that is epsilon xx is equal to 1 minus nu k by 1 minus k square into epsilon xx minus of k into epsilon yy cap. So this equation means these two values are measured values, this is the corrected value. So these are the correction factors, that is nu, and k is the transverse sensitivity factor, k square, somewhere it will be written as kt, transverse sensitivity factor. So this have to be considered. So similarly for, and here only two gauges are there, so that's why we are going to take epsilon xx and epsilon yy. So there is only two gauges. And similarly principal strains can be obtained by this also, where this is the principal strains which are measured, this is corrected principal strains, similar. Okay, next we move on to the 3-element rectangular rosette. 3-element rectangular rosette, it's also similar way, but you have 3 gauges, epsilon a, epsilon b and epsilon c. These caps indicated it is a measured value, means it's only a measured value, it should be corrected. So how you are going to correct? By putting the correction factor. So epsilon a is equal to 1 minus nu k by 1 minus k square into epsilon a cap minus k into epsilon c cap. So by this equation, if you remember this equation, you will get the corrected strain. Similarly epsilon a, you have this equation, epsilon c, you have this equation, where only the interchange of c, epsilon c and epsilon a is going to be taking place. But for the epsilon b, okay, for epsilon b, just remember this equation. Okay, epsilon b is equal to 1 minus nu k by 1 minus k square. This is similar. In here this term is going to change as epsilon b cap minus of k into epsilon a cap plus epsilon c cap minus epsilon b cap. So this type you are going to make the correction for the this 3-element rectangular rosette. Just remember these equations. These are the important equations, epsilon a, epsilon c and epsilon b, whenever transverse sensitivity is considered. So next problem which we are going to do, it is basically depending upon these 3 equations. Okay, if you remember these 3 equations, you can easily solve those problems. Okay, now we move on to the problem. Okay, this is the second problem. First we read it. The 3-element rectangular rosette is mounted on a steel component with capital E is equal to 204 GPa and nu is equal to 0.3. The manufacturer gauge factor F and cross sensitivity KT is 2.8 and 0.06 respectively. The reading corresponding to the 3 gauge as indicated under strain meter with the gauge factor control set at 2.8 or epsilon naught, that is E naught or epsilon naught, which is equal to 700 microns. You can see epsilon 0, which represents the angle of that gauge. Epsilon 0, it is 0 angle, so theta will be equal to 0. Epsilon 45, that is minus 50 microns, and epsilon 90, which is equal to minus 70 microns meter per meter, and nu naught, which is equal to 0.26. So nu naught is used whenever the correction factor is going to be considered. Okay, and only nu, which is going to be used when there is no correction factor is used. Okay, so you have to distinguish these two values. So see this, what are the things you have to given data, that is Young's models they have given 204 GPA, new 0.3, gauge factor 2.8, the cross sensitivity is a transfer sensitivity factor, it's also 0.06, and the strain values they have given, these are the measured values, means for the 0 angle strain gauge 70 microns, for 45 angle strain gauge minus 50 microns, and 90-degree strain gauge minus 700 microns meter per meter, and it can be taken as measure value that we have I have written here, epsilon A cap, epsilon B cap, and epsilon C cap, and nu naught is considered for the strain gauge where the correction factor is considered. So first we are going to determine this corrected strains. Okay, corrected strains, epsilon A is equal to 1 minus nu naught kt by 1 minus kt square. So this equation we have just briefed in the transfer sensitivity, the same equation in here, 1 minus nu naught kt by 1 minus kt square, I just written in the terms of kt in the place of nu naught. So just to differentiate the values, epsilon A cap minus epsilon kt into epsilon. Okay, so here this is the equation for the correction, means this is the value which is corrected strands, this is the measured strands. So what we do, we just substitute the values. You can know nu naught in terms of nu naught value, we are going to write 0.26, kt 0.06, and epsilon A that is the measured value, that is 700, we are going to take epsilon A cap, so that is 700 microns, and 0.06 it is the kt value which is given in here, and you have substituted, and similarly this is epsilon C 700, it is minus 700 epsilon C is, so in here the whatever the sign going to change, it is will be positive, so you are going to substitute the values, and similarly you are going to get epsilon A, that is 733.063 microns. You can see here the epsilon A cap, it is 700 microns, in here there is some variation, that is epsilon A, this is corrected 733.063 microns. So you can see what is the variations because of the transfer sensitivity. Similarly, epsilon C, you have the similar equation, only the epsilon C cap and epsilon A cap interchanged, and you are going to get the minus of 733.063 microns. Okay. Next we move on to this epsilon B. So this is somewhat changed equation. Epsilon B 1 minus nu naught kt by 1 minus kt square, epsilon B cap minus of kt into epsilon A cap plus epsilon C cap minus epsilon B cap. So you have to remember this equation. So for to determine the measured epsilon B, that is minus 52.361 microns. So by using this epsilon A, epsilon B, epsilon C, you are going to substitute in this term of principal stresses. Here you are going to determine the principal stresses and their direction by using the corrected strains and directions. Okay, so see here, this is sigma 1 comma 2 equation. So this equation is also obtained where you have done the 3 element rectangular rosette expression derivation. So where you get this sigma 1 comma 2 equation, that is E into epsilon A plus epsilon C by 2 into 1 minus nu plus or minus 1 by 2 into 1 plus nu root of epsilon A minus epsilon C whole square plus 2 epsilon B minus epsilon A minus epsilon C whole square. So this equation you have to remember, just you have to substitute the values now. You got the epsilon A, epsilon B and epsilon C values in the above equations. This is epsilon B value, epsilon A value and epsilon C value. So just using these values you are going to substitute in here and you are going to get the principal strains. I just substitute that values in here and you have got the sigma 1 and sigma 2 results, that is 1.1532 into 10 raised to 8 Newton per millimeter square. Sigma 2 is equal to minus of 1.1532 into 10 raised to 8 Newton per millimeter square. So now you have to determine the angle. So you can see this tan 2 phi, this equation you have to remember, 2 epsilon B minus epsilon A minus epsilon C by epsilon A minus epsilon C. You substituted the values and you are got to the phi 1, that is minus of 2.04. So phi 2 we can determine by just adding 90 degree. Okay, So next, finally, you have to determine the principal stresses using given stresses. Okay, so first part you have done, it is for the corrected strains. Now you are going to see this for the measured strains, means you are directly putting epsilon a cap values in here. Okay, the same equation, just you have to substitute the epsilon a cap values. Where 732 is substituted, here you are going to substitute 700, okay, microns, and 52 you are going to substitute 50 microns. So by that you are going to get this equation, somewhat changed sigma 1 and sigma 2 values you have got. Okay, so it is just to determine what is the error percentage. Okay, so this is the percentage of error you have to determine, that is corrected stresses minus given stresses and by corrected stresses into 100. Okay, so by that you are going to get this equation. So the error percentage will be 4.53%. This is the variation of stress which is obtained if you compare the measured strains and the corrected strains. Means correction is because of transverse sensitivity. So like that you have to see this problem. Okay. Okay, next we move on to the delta Rosette problems. It's also very important since many times they have asked the delta Rosettes only. So in here you can see this problem. A delta Rosette yields the following strain indications: epsilon A is equal to minus 845 microns, epsilon B is equal to 1220 microns, and epsilon C is equal to 710 microns. Calculate the maximum principal strains, principal strain directions, principal stresses, and maximum shear stress. They have given a Young's modulus 200 GPa and the Poisson's ratio 0.285. So you can see here there is no correction factor values they have given. So there is no transverse sensitivity is considered in this problem. Just a simple without transverse sensitivity. So you can see here. So you have, these are the given values. Solution. So you know this epsilon A value, epsilon A value is equal to epsilon XX. So that will be taken as minus 845 microns. So this will be calculated in the delta Rosette expressions in the earlier derivation. Okay, so you have to remember this: epsilon A is equal to epsilon X minus 845 microns. Similarly, epsilon Y is equal to 1 by 3 into this equation is also determined in the earlier. Okay, so the same thing you have to remember in here. Next, you have to substitute the values and you have got the epsilon Y. Okay, similarly gamma xy is also this equation 2 by root 3 into epsilon b minus epsilon c. So if you substitute that, you are going to get gamma xy, that is 588.90 microns. Okay, so in this way you have to find. So these three equations are very important: epsilon x which is equal to epsilon a, epsilon y which is equal to 1 by 3 of this term, and gamma xy is equal to 2 by root 3 into epsilon b minus epsilon c. So these three equations you have to remember. Okay, just substitution. Next, you have to remember the principal strain equation. This is common equation. You can generally remember this equation, so that half of epsilon x plus epsilon y plus or minus 1 by 2 into root of epsilon x minus epsilon y whole square plus gamma xy square. If you substitute the values, you will get the epsilon 1 and epsilon 2 values, that is principal strains. Similarly, gamma max can be determined by this equation: epsilon x minus epsilon y whole square plus gamma xy square. You will get the gamma max. Principal directions. So principal directions you can determine by this equation, that is phi 1 is equal to half of tan inverse of gamma xy by epsilon x minus epsilon y. So this term, if you substitute the value, you get phi 1. If you add the 90 degree, you will get the phi 2. Okay. Principal stresses, you know this basic equation, that is sigma 1 is equal to E by 1 minus nu square, epsilon 1 plus epsilon nu into epsilon 2, or you are going to get the sigma 1 is equal to 294.432 megapascal. Similarly, epsilon 2, if you substitute, you are going to get minus 92.154 megapascals. Tau max E by 2 into 1 minus nu gamma max. If you get the tau max value, 193.32 megapascals. So like that you have to solve these problems. Okay, so this is the delta Rosette problems, and there is one more problem. I just give assignment for you. There is nothing different here. In this the delta strain Rosette is bonded on the surface of a structural member and made of aluminum yield the following strains when the structure is loaded: epsilon naught 550 microns, epsilon 120 minus 22.5 microns or 225 microns, and epsilon 240 is 300 microns. Given KT, so KT is given, so it is a transfer sensitivity factor, and new value is given. So you have to determine the magnitude and directions, principal strains, and the point where the strain rosette is bonded. Okay, so like that you have to calculate. You have to just a similar way. This is the transfer sensitivity correction value. So in here the same equation. So I have given the notes for this, how this equation is obtained. This equation should be remembered for to get the corrected strains. So you have to remember this equation, just substitute the values. Similarly, epsilon b, you have to remember this equation, and epsilon c, you have to remember this equation. You will get epsilon c value, epsilon a, epsilon b value. And next, finally, you are going to get epsilon 1 comma 2 by substituting these values in this term, and you are going to epsilon 1 comma epsilon 2 values, and you have to next you have to determine the stresses value. Okay, first is the angle. You have to determine the angle, then you have to determine the this sigma 1 and sigma 2 values. So like that you have to determine the values by using the basic equations. Okay, so I will leave on to you this problem. You have to solve this. Okay, it's a just substitution problem. You have to remember the equation and you have to substitute there. Okay, so thank you students. I think you got the better idea how the problems are there in the second unit, and just these problems are very important because in this problems you are going to get the maximum marks in this module. Okay, so don't neglect this part. Just observe all the problems and study it. Just you have to remember some equations so you can get through it. So I will send these notes to you all. Just refer it, and I have given the assignments. There are a lot of problems in there. You have to use these methods and you have to solve those problems. Okay, I think if you have any doubts, any queries, you can message me or you can call me. Okay, thank you.